So in this video, we'd like to talk about Euler's formula. So Euler's formula states that e to the I theta equals cosine theta plus I sine theta. So I'm assuming that you're familiar with complex numbers, so let's just quickly review that. So if we have a complex number z, z equals a plus ib. So a is the real part of the complex number. So if we have here a real axis and we have an imaginary axis, so a is the distance along the real axis, that's a. And then if we draw a perpendicular and we take a distance b, move along a distance b, then this point here is a plus ib. That's the complex number z equals a plus ib. And if we connect that point to the origin, then the distance from that point to the origin is equal to the magnitude of the complex number, and we represent that by the symbol, So that's the magnitude of the complex number z. So magnitude of z equals, here we have a right angle triangle. One side is equal to a, the other side is equal to b. So the hypotenuse equals the square root of a squared plus b squared. So the magnitude of z is a squared plus b squared. So let's look at the right hand side of Euler's formula, cosine theta plus I sine theta. So we have a complex number z equals cosine theta plus I sine theta. So just like we did here with a and b, let's repeat that down here. So the real part of the complex number is equal to cosine theta. And then if we draw a perpendicular here, and then draw the distance sine theta, and this is a right angle, then the point here, so we've moved along the real axis a distance cosine theta, and then we moved along the imaginary axis a distance of sine theta. This point here is cosine theta plus I sine theta. Okay, how about the magnitude of that complex number? So the magnitude is the distance from the point to the origin. It's this distance here. And we said that equals, so magnitude of z equals to square root of cosine squared theta plus sine squared theta. Cosine squared theta plus sine squared theta equals 1, so that equals to the square root of 1, that equals to 1. Which means that cosine theta plus I sine theta is always equal, has a distance, is always a distance of 1 from the origin, regardless of the value of theta. How about the angle? Let's call this angle alpha. Let's call this angle alpha here. So for our case here, tan alpha equals b divided by a. So we have a right angle triangle, angle alpha, side a, this is alpha, this is b. So tan of alpha equals b divided by a. How about this triangle here? So we have, so tan alpha for, let's call this z1 and let's call this z2. And let's call this alpha 2. So this is our angle here, alpha 2. So tan alpha 2 equals sine theta. That's this side here of the triangle divided by cosine theta. So that equals tan theta. So tan alpha 2 equals tan theta, which means that alpha 2 equals to theta, which means this angle here equals to theta. So what does the formula, what does Euler's formula state? It states that e to the I theta equals cosine theta plus I sine theta, where e is the base of the natural log. So it's just a different way of representing this complex number. So z equals e to the I theta is a complex number that always lies on the unit circle. Always lies on the unit circle. We just showed here that cosine theta plus I sine theta, that complex number, has a magnitude of 1 independent of theta, so that applies to this number here. So the magnitude of e to the I theta equals 1 independent of theta. So let's give some examples. So let's see, we have our real axis and imaginary axis. So this angle here equals 180 degrees, and in radians that equals pi. So 180 degrees equals to pi in radians. 90 degrees would be equal to pi over 2. 45 degrees would be equal to pi over 4. So if we have our real axis and imaginary axis, and we drew a circle which has a radius of 1, so this point here on the unit circle would be e to the I pi over 2. This number here along the real axis would be equal to e to the I pi. And the point here in which the complex number makes an angle of 45 degrees, so if we do that 45 degrees, then the point here would be e to the I pi over 4.